hydrogen was taken as a standard. Hydrogen valency was assigned to be 1. So valency of any other element was equal to what? Was equal to the number of hydrogen atoms with which it combines. Try to answer this. What is the valency of carbon in methane?
4.
4.
Four.
The valency of carbon in
2.
methane is
4.
4. What is the reason?
Because it combines with 4 hydrogen atoms.
Very good. Because one atom of carbon is combining with 4 atoms of hydrogen in methane molecule. That is why valency of carbon in methane is 4. So this was valency with respect to hydrogen. So in today's class, we will be discussing valency with respect to electron. Okay. Okay. So first let us come from the basics. Let us recall basics. Atom is neutral, correct? So why is an atom neutral? Because
Excuse me, ma'am.
It has
Ah.
an equal.
Excuse me, ma'am.
yes.
Ma'am, actually, there's a guy called Parin, ma'am. He's in queue, ma'am. He's just waiting.
I can't see anyone here. No. Okay, wait. Thank you.
Yes, ma'am. No problem.
One second. Anybody else still waiting? No, right? Okay, let us continue. Children, shall we continue?
Yes,
ma'am.
Okay.
Yes, ma'am.
So in today's class, we are starting with valency with respect to electron. Okay. So we all know atoms are neutral. Why is an atom neutral? Because the number of positively charged particle, which is nothing but the number of protons in an atom, will be equal to what? The number of electrons. So that is why atom is said to be neutral. Okay. So what happens? One by one, they are joining now. Okay. So let us see what happens if an atom loses or gains electron. Okay, I'm taking it as let the atom be X. So if atom means it is neutral. So in an atom, P is equal to E. If an atom gains electron, what happens if an atom gains electron? The negative charge in an atom will increase, correct? The atom will acquire a negative charge. Similarly, if an atom loses electron, the number of protons will be more. So an atom will get a positive charge. So these charged particles are called what? They can be called ions. Correct? So when is an ion formed? When an atom loses or gains electron. Okay. Now in today's class, we'll continue with valency with respect to electron. There we are learning what type of valency do metals show, what type of valency do non-metals show. Okay, so metals generally have what? They have 1, 2 or 3 electrons in their valence shell. Yes or no? For example, sodium, magnesium, sodium atomic number 11, magnesium atomic number 12, aluminium atomic number 13. I'm writing their electronic configuration here. Sodium configuration is 281, magnesium 282, aluminium 283. So you can see here metals generally have how many electrons in their valence shell?
1, 2, or 3.
Oh, 1, 2, or
So
3.
they are having 1, 2, or 3 electrons in their valence shell. So when any element, if it has 1, 2, or 3 electrons in its outermost shell, it has a tendency to lose electron. Why will it lose electron? So that it can acquire stability. So it can attain stability by acquiring the nearest noble gas configuration. So sodium atom has a tendency to lose one electron. Either you can write minus continuously, children. It's if they don't join on time, it is like disturbance in between the class. Okay. So sodium atom has a tendency to lose one electron. Magnesium atom similarly loses how many electron? Loses two electrons. Aluminium has to lose three electron. So they will lose. So what does sodium become? It becomes a sodium cation, Na plus ion, which is simply called sodium ion, whose configuration is 2,8. So this is a stable electronic configuration of which element?
Sodium.
A 2,8 is a configuration of which
Neon.
noble gas? Neon. Similarly, magnesium is losing two electrons. So it will form what ion? Mg2 plus ion. So Mg2 plus has configuration of 2,8 now. So magnesium has lost two electrons and it has attained stability by acquiring the nearest noble gas configuration of neon. Similarly, aluminium can lose 3 electron. It should lose 3 electron so that it will form Al3 plus ion and attain stability by acquiring the stable electronic configuration of the nearest noble gas, which is neon. So what do you observe here? You observe that metals generally have a tendency to lose electron. They generally have 1, 2, or 3 electrons in their outermost shell. So they will lose 1, 2, or 3 electrons from the outermost shell and they become stable. So they form what ions? Generally metals form positive ions, okay, because they have a tendency to lose electron. So metals exhibit what valency? Generally, metals exhibit positive valency. Okay. So valency is nothing but the charge on the ion. Sodium has +1 charge. It means valency of sodium is +1, also known as univalent. Okay. Magnesium, what is the charge on the ion? +2. So valency is +2. Aluminium, charge is +3. So valency is +3. So valency +2 can be called as what? Divalent, or it can also be called bivalent. Valency +3, trivalent. Followed? So what is the valency of a metal? Valency of a metal is the number of electrons lost. How many electron is it losing? How many electrons here? 2 electrons magnesium is losing. So valency is the number of electrons lost per atom of the metal. That will be the valency of metal. Now let us go to non-metals. Okay. So nitrogen. What is the atomic number of nitrogen? First 20 elements, do you know?
I'm 7.
7.
Nitrogen is the seventh element in your periodic table. Electronic configuration is 2, 5. Is it easy for nitrogen atom to lose 5 electron or gain 3 electron and try to attain the nearest noble gas configuration?
Gain
Gain
3.
3 electrons. Gain 3.
That is why nitrogen atom will gain 3 electron. Plus 3 electron means I'm writing it as it gains 3 electron. One and the same. You can write in either way. Okay. So nitrogen having a configuration, electronic configuration of 2, 5, because it has 5 electron in its outermost shell, it has a tendency to gain 3 electron. So nitrogen will get a charge of 3 minus. Electrons are more now. So this ion is called what? This ion is called as nitride ion. Non-metallic name should end with IDE, the ion name. Who is this? Which child with different names they are trying to join? Okay. So similarly, oxygen, atomic number 8, electronic configuration 2, 6. So oxygen has to gain how many electron now?
2, ma'am.
2.
2.
So
2.
oxygen gains 2 electron. So what will be the charge on oxygen?
O2 minus.
2 minus.
2 minus. So this ion, oxygen, oxide. Can you see the non-metallic ion name is ending with IDE, oxide ion. So valency is nothing but charge on the ion. So nitrogen valency is -3, oxygen valency is -2. Valency 3 plus or minus. In general, it is called what? Trivalent. 2, divalent or bivalent. Fluorine, atomic number 9, electronic configuration 2, 7. So fluorine atom has a tendency to
Gain 1 atom.
Gain 1.
electron. Correct. Gains 1 electron. What will be the charge on fluorine atom? 1 negative charge. So what is this ion called? Fluoride ion. Okay. So valency is -1. So valency for non-metal in general is the number of electrons the non-metal gains. Okay. So one atom of fluorine has a tendency to gain 1 electron. That is why valency of fluorine is -1. Oxygen, one atom of oxygen has a tendency to gain 2 electron. That is why oxygen valency is -2. Is that clear, children?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Now
Yes,
let
ma'am.
us
Yes, ma'am.
let us discuss first 20 elements with its valency. Okay. You can write in your book whatever we are writing now, you can note down in your book. Okay. Please write, I'll check it during regular class. Element name, symbol. Okay. Electronic configuration. Type of element. Type of element means whether it is metal, non-metal, metalloid, noble gas, that you will write. Okay. Valency. We'll write for first 20 elements. So first element, hydrogen. What is the symbol for hydrogen? H. So hydrogen atomic number, first element means atomic number is 1. So electronic configuration is just 1. Last year, you remember you have learned electronic configuration, distribution of electrons in k element shell.
Yes, ma'am.
Yes,
Okay,
ma'am.
this is just for your reference. I'm writing k element. Otherwise, also you can just write 1. That is also fine. Okay. So hydrogen, what type of element is it? In the periodic table, open your textbook at the end. You see periodic table. Tell me, where do you find hydrogen? It is there in which group? Which group? Which period? Check in the textbook and answer me. It is there in period 1, first period, correct?
Ma'am, but we don't have our textbooks.
Okay, you don't have your textbook. Last year also you have learned, right? Like hydrogen is the, like in the periodic table, period number 1, there is
Yes, ma'am.
hydrogen, there is helium, correct? In period 2, you will start with which element? Lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine, then neon. Above fluorine, there was again hydrogen placed. Do you remember this? Hydrogen has been placed at 2 places in the periodic table.
Yes,
Yes,
ma'am.
ma'am.
It is being given position with the metals. It is also being given position with the non-metals. At least this much were you aware last year?
Yes, ma'am.
Okay. Why is that? More in detail again this year you will learn. Last year also you have learned. Correct. Hydrogen shows some property which is similar to metal. Hydrogen atom having 1 electron in its outermost shell, hydrogen has a tendency to gain 1 electron. If it gains 1 electron, what type of ion does it form?
anion.
Ah, how do I represent that anion?
H minus.
Minus.
See, hydrogen atom, if it gains one electron, like non-metals, fluorine, chlorine, bromine, iodine, they all have a tendency to gain one electron, right? So this ion is called what? Hydride ion. Please write whatever I'm writing, you also note down. Okay. Hydrogen atom, like metals, if it loses one electron, then it will form H plus ion. H plus is nothing but just a proton. Understood? Hydrogen atom has only one proton, only one electron. If that electron is lost, what is just? It is nothing but a proton. So H plus is nothing but a proton. H minus ion is called hydride ion. Okay. So hydrogen shows property, some property similar to metal, some property similar to non-metal. So still it is ambiguous. So hydrogen can be classified metal and non-metal. So valency can be +1 or valency can be -1. Done? More in detail, we'll again discuss. You have one separate chapter, hydrogen. There we'll discuss properties similar to metals, properties similar to non-metals. All those we will learn there. As of now, you should be able to write electronic configuration. What is its valency? We are learning valency. Okay. Understood, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
I'll move on to the second element. Which is the second element? Helium.
Helium.
Symbol is He.
He.
So atomic number 2, it means proton is 2, electron is 2. So the 2 electrons, where should I allot? It will go to which shell?
K
shell.
First
K
shell.
shell. K shell, correct. Helium atom has only one shell, which is a K shell. What is the maximum capacity of K shell?
2.
2.
Two.
Why is it 2? Why is it 2?
2n square rule.
Correct. According to your 2n square rule, which is also known as Bohr-Bury rule. Okay. So the maximum amount of electrons in a given shell is given by a formula 2n square. What does n represent? N represents shell number. So according to that, n value is 1 for K shell. So for K shell, 2 into 1 square. So maximum of 2 electrons can be there in the K shell. So K shell is complete. Yes or no? For helium, K shell is complete. Okay. So helium atom has no tendency to lose electron, gain electron. That is why because the K shell is complete, so helium atom has no tendency to chemically combine. It doesn't lose electron, it doesn't gain electron, or it doesn't share electron. So valency of helium will be 0. What type of element is helium? Noble.
Noble gas.
It doesn't form ion. Okay. Now moving on to the third element. Which is the third element? Lithium. Symbol is Li. So atomic number 3. Electronic configuration will be 2,
1.
1. So 2 electrons in K shell. The next electron goes to L shell. So this element, lithium, has 1 electron in its valence shell. So it has a tendency to lose electron or gain electron.
Lose.
Electron. So it will lose electron, means it will exhibit a valency of +1. What will be the ion formed?
Cation.
Cation, Li plus. So what type of element is lithium? It is a
Metal.
metal. So how do you identify? Look at the outer electronic configuration. This element has 1 electron in its outermost shell. Okay. Now which is the fourth element? Beryllium. Are you writing with me?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, so beryllium electronic configuration is 2, 2. So beryllium has a tendency to lose 2 electrons. So valency will be +2. Beryllium will be Be2 plus. What type of element is beryllium? It is a metal. Okay. Fifth one, boron. Symbol is B. Atomic number 5. So electronic configuration 2, 3.
Okay.
So what type of element is boron? Among 1 to 20, you should remember you have two metalloids. Which are they?
Boron. Boron and silicon.
And
Silicon.
silicon. Okay. Okay. So boron is a metalloid. It has a tendency, because it has 3 electrons in its valence shell, it will exhibit a valency of +3. Okay. Which is the sixth element? Carbon.
Carbon.
Symbol is
lithium.
yeah. Tell me. Should I go up?
Yes, ma'am.
Is it fine now?
Yes, ma'am.
Yes, ma'am.
Okay, carbon symbol is C, atomic number 6, electronic configuration 2, 4. So carbon has 4 electron in its outermost shell. Carbon atom valency is just 4 because carbon generally shares electron. You will see, like for example, methane, CH4, where carbon having 4 electron in its outermost shell will combine with 4 different hydrogen having 1 electron. How do they become stable? By sharing electrons mutually. That type of bonding is called as covalent bonding, which you will be learning in detail under the chapter chemical bonding. Okay, that is why there is no plus or minus. Carbon atom generally shares electron. Okay.
Ma'am, I have a question.
Oh, I still didn't finish. Tell me, what is it?
Ma'am, I have a doubt about the carbon, ma'am. Doesn't carbon gain 4 electron and form carbide?
Carbides, when it combines with metal. That is why I told I still didn't finish. I expected somebody will ask this. Under valency -4, you also have carbide ion. When carbon combines with metals, it forms respective metal carbides. Only in metal carbides, carbon valency is -4. This is the carbide ion. Okay. So otherwise, generally in most of the organic compounds, like methane is an organic compound. Organic compounds are those compounds made up of what? Mainly carbon, hydrogen and oxygen. So carbon can share electron also, and it can form what? Covalent bonding. So what type of element is carbon now? Carbon is a non-metal. Okay. Shall I go to the next one?
Yes, ma'am.
Yes, ma'am.
Okay. Seventh element.
Nitrogen.
Nitrogen. Symbol is N. Don't write N2. Okay. We are writing symbol for an element.
Ma'am.
So electronic configuration 2, 5. So nitrogen is a non-metal. Now,
Excuse me, ma'am.
yes.
Ma'am, can we write carbon as C plus 4 also?
No, because it will combine with a metal. Metals will have positive valency there. Carbon is a non-metal. Generally, negative valency is exhibited by non-metal. So, carbide ion has negative valency. But if carbon is forming a compound by sharing electron, then valency is just written for no plus or minus.
Okay.
Okay.
Yes.
So nitrogen has 5 electron in its outermost shell. So it has a tendency to gain 3 electron. Correct? So what ion will it form? It will form nitride ion. Okay. So valency -3. N3 minus or -3. Any way you write. What is ion? Nitride. For metals, for example, lithium ion, sodium, just we say sodium ion. But in case of non-metals, the nomenclature means naming says that for the non-metallic ion, the name should end with IDE. Okay.
Yes, ma'am.
Now eighth element, oxygen, which is the ninth element,
Fluorine.
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 10th element,
Neon.
okay. So oxygen symbol is O, fluorine is F, neon is Ne, because N is a symbol for nitrogen. So atomic number 8, electronic configuration 2, 6. Here atomic number 9, so 2 comma 7. Atomic number 10, so 2 comma 8. Look here, if an element has 5, 6 or 7 electrons in its outermost shell, it has a tendency to gain electron. So nitrogen gains 3 electron, so valency is minus 3. Oxygen gains 2 electron, fluorine gains 1 electron. So they will show valency, negative valency, minus 3, minus 2, minus 1. So oxygen will form O2 minus ion, which is called oxide. Children, don't write like this O2 minus. This is wrong. The first one is wrong. Did you understand why it is wrong?
Yes, ma'am.
Why is it wrong? Explain.
Because there are two atoms of
That is oxygen molecule. Correct. First one is oxygen molecule. We are talking about atom. When it loses or gains electron, it will form an ion. This is totally wrong. Oxygen atom has a tendency to gain 2 electrons. So charge will be 2 minus the number of electrons gained. Is so many still they are joining now. Okay. What about fluorine? What is the ion formed? F minus. What should it be called? Fluoride ion. 1 minus you write or simply minus you write. Everything is right. Okay. Fluoride ion. Okay. So all these are what? They are non-metals. What about neon? The outermost shell is 8. 8. So it means it is complete. Correct. It has been found in nature. Those elements which have 8 electrons in their outermost shell, they have no tendency to lose electron, gain electron, or share electron. They are happy on their own. Okay. They are chemically non-reactive. They are stable. So these elements are nothing but they are called noble gases, or they are also known as inert gases. Okay. So valency of neon is 0. Okay. Now I'll tell you something which you will learn this year, and you will be learning again and again, even in under chemical bonding. Okay. See, the first noble gas what you had is helium. Correct. It has only one shell, K shell. K shell maximum. For example, imagine this is a nucleus. The first shell is K shell. K shell capacity is 2. So the K shell is completely filled in case of helium. So the arrangement of 2 electrons in its outermost shell and being stable on its own, this configuration is called duplet configuration. Have you heard this name before?
Yes,
No, ma'am.
Yes, ma'am.
Okay. So duplet configuration refers to, note down, okay. Duplet configuration refers to the arrangement of 2 electrons in the valence shell as seen in case of helium. Helium element shows duplet configuration. Only helium element has duplet configuration. So the arrangement of 2 electrons in its outermost K shell and being stable on its own as seen in case of helium. This configuration is called duplet configuration. Now, other than helium, all other noble gases, they have how many electrons in their valence shell? Generally, they have 8 electrons in their outermost shell. For example, I'll draw now neon. Nucleus, I'm just representing it by positive charge. And neon has how many shells? Neon has 2 shells, correct? In the K shell, I may not be able to draw very neatly on the whiteboard, here, but you're able to understand, right? So in the K shell of neon, you can see how many electrons are there? 2 electrons. Then in the L shell, how many electrons are there? 8 electrons are there in the L shell. So the arrangement of 8 electrons in its outermost shell and being stable on its own, this configuration is called octet configuration. So duplet configuration and octet configuration, they refer to what? They refer to stable electronic configuration. So stable electronic configuration is seen in which elements? It is seen in noble gases. Did you follow?
Yes, ma'am.
So neon shows what configuration? This configuration is called octet configuration, having 8 electron in its outermost shell. That configuration is called octet configuration. Okay, children.
Yes, ma'am.
Now, shall we continue from the 11th element now?
Yes, ma'am.
Yes, ma'am.
Okay. So which is the 11th element in the periodic?
Sodium.
Sodium. Symbol?
Na.
Na. Latin name?
Natrium.
So 12th element?
Magnesium.
Magnesium. Symbol is
Mg.
Mg. 13th element?
Aluminium.
Aluminium. Symbol Al.
Al.
So what is the electronic configuration for sodium?
281. 281.
281. See, L shell, according, lot of background noise, children. Mute yourself only when you're answering, unmute. Okay. So sodium atomic number is 11. So electronic configuration is 281. L shell maximum capacity is 8. Correct. So the next electron enters the next shell. So similarly, magnesium electronic configuration is 282. Aluminium electronic configuration is 283. What do you observe? These elements have 1, 2 or 3 electrons in their outermost shell. So if they have 1, 2 or 3 electrons in the outermost shell, they have a tendency to lose electron. So sodium loses 1 electron. So valency is +1. Magnesium loses 2 electron. Valency is +2. Aluminium loses 3 electron. So valency is +3. Okay. So all these 3 elements are, what type of elements are they? They are metals. Okay. Let us write their ion. Now how do I represent sodium ion?
Na plus.
Na plus.
Plus. Magnesium ion?
Mg2
Mg2 plus.
Mg2 plus. Aluminium ion?
Al3
Al3 plus.
Either you write +3, 3 plus, one and the same. Okay. Now moving on to 14th element, silicon. Correct. Symbol is Si. So 284. It generally shares electron like carbon. Okay. Valency is 4. What type of element is silicon?
Metalloid.
Metalloid. Okay. Now which is the 15th element?
Phosphorus.
Phosphorus. 16th one?
Sulfur.
Sulfur. Okay. 17th one?
Chlorine.
Chlorine. Okay. Symbol for phosphorus is P. Sulfur is S. Chlorine Cl. So atomic number 15, electronic configuration 285. Sulfur 16, 286. Then chlorine 17, 287. So what do you observe here? These 3 elements have 5, 6 or 7 electrons in their outermost shell. If an element has 5 electrons in its outermost shell, it has a tendency to
Lose.
gain
Again.
electron.
gain. So it has to gain a 3 electron. So valency is what? -3. So what ion I will get?
Phosphide ion.
P3 minus.
P3 minus. Okay. Similarly, sulfur gains 2 electron. S2 minus. Chlorine gains 1 electron. Cl minus. Again, I'll come back to variable valency shown by phosphorus and sulfur. After I discuss variable valency, I'll tell you these elements also show variable valency that we will discuss. Okay. So generally, which elements have a tendency to gain electron? Non-metals. Phosphide, sulfide, chloride are their names. Okay. So phosphorus gains a 3 electron to attain stable electronic configuration of which element, children?
Argon.
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 Argon. So your 18th element is argon. Symbol is
AR.
Ar. So electronic configuration
288.
288. So what do you see in the valence shell? Valence shell is nothing
Eight.
but the outermost shell. So outermost shell has how many electron?
8.
8. So having 8 electron in its outermost shell, what configuration is it?
Octet configuration.
So this configuration is octet. Okay. So argon has 8 electron in its outermost shell and it is stable on its own. It has no tendency to lose, gain or share electron. It is chemically non-reactive. Valency is 0. Okay. So noble gases have what valency?
0.
0 valency. Okay. 19th element, which is the 19th?
Potassium.
Potassium. Then 20th element is
Calcium.
See, up to your grade 10, first 20 elements, their electronic configuration, valency, ions, everything you should know. Only first 20 elements, without fail, you should know. Okay. What is the symbol for potassium? K.
K.
What's the name?
Helium.
Calcium.
Gallium.
Symbol for calcium is
Ca.
right. So potassium atomic number 19. So electronic configuration is
2881.
281. Why can't I write 289? Is it correct to write 289?
No, ma'am, because the last shell cannot
Because the
support that
maximum
8.
capacity of the M would be 8.
Yeah, the outermost shell cannot have more than 8 electrons. It has been found in nature. Those elements which are stable, they maximum have only 8 electrons in their outermost shell. That is why one electron will jump to the next energy level. That is why potassium valency is 2881. What about calcium? Continue the same trend.
282.
82. So what do you observe here? Potassium has 1 electron in its valence shell. Calcium has 2 electron in its valence shell. So potassium atom loses 1 electron. So what ion will it form? K plus. Calcium ion has a tendency to lose this 2 electron. So calcium will form Ca2
Ca2 plus.
ion. So valency is nothing but charge on the ion. So valency of potassium is +1. Valency of calcium is +2. So these two elements are metals. Yes, sir?
Yes, ma'am.
Yes,
Did
ma'am.
you all finish writing?
Yes, ma'am.
Yes, ma'am. We're done.
Yes, ma'am.
Yes, ma'am.
Okay. Now, there is something called variable valency. Last year you learned
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
what is the meaning of variable.
It
Not
can be two
Valence-
different
The
things.
valencies vary, ma'am.
Two different valency from the same element.
Some elements have a tendency to exhibit more than one valency. Okay, let us go through these slides, answer the questions which are here. Okay. See, metals and hydrogen have positive valency. Correct. If hydrogen is H plus, then it will show a valency of +1. Correct. Now we answer. What is the valency of magnesium and aluminium?
Magnesium is 2 plus, aluminum is 3
3 plus. 3
Correct.
plus.
Magnesium valency is +2. It is bivalent. Aluminium valency is +3 because electronic configuration is 283. Aluminium is trivalent. Okay. Non-metals or group of non-metals can also have negative valency. So the formula of the radicals and all, one by one, when I start the valency chart, we will discuss. Okay. See, one example I have given here, chlorine atom. So chlorine gains 1 electron to form chloride ion. So valency is -1 and it is univalent. So what do you observe? For a non-metal, the number of electrons gained will be its valency. Recall, what is the valency of sulfur?
2
Mine.
minus 2.
-2.
Immediately, children, see, In grade 9, if I tell sulfur, you should be able to recall atomic number 16. You should know their atomic numbers. Okay. 16. So 286, 6 electrons in the outermost shell. It has a tendency to gain 2 electron. Okay. So valency is -2. And what is the valency for nitrogen?
Minus
Minus
3.
3.
Is 3.
-3. Why is it -3? What is the electronic configuration?
285.
8,
2,
5.
2,
The
5.
seventh element in your periodic table. So 2,
5.
5.
No,
So
2,
it
5.
gains 3 electrons. So valency is -3. So this is what we just discussed, the small table, but one by one we have written in the book. See, lithium and sodium both have 1 electron in the valence shell. So they show valency of 1. Beryllium and magnesium, valency 2. Boron, aluminium, valency 3. Carbon, silicon, valency 4. Nitrogen, phosphorus. Again, how does valency vary in the periodic table? It will go like 1, 2, 3, 4. Again 3, 2, 1, 0. I think this you learnt even in grade 7, correct?
Yes, ma'am.
Yes,
Okay.
ma'am.
So metals generally lose electron. Non-metals generally gain electron. Carbon and silicon can share electron. Okay. So variable valency. How much time left?
Ma'am, 4 minutes.
Ma'am, 5 minutes.
4 minutes.
4 minutes. Okay. Shall I start with variable valency or we'll start in the next class?
Ma'am, we can start in the next class.
Okay. Okay, let us now just recall. Okay, I'll tell you the metal, I'll tell you the element, you tell me what type of elements are they. Okay. Helium.
Noble gas.
Noble gas.
Gas.
Valency. Valency.
0.
0.
Calcium.
Metal.
Plus.
Valency plus 2.
Metal. Valency plus 2.
Plus
Correct.
2.
Oxygen.
No.
Non-metal. Valency minus 2.
Non-metal plus 2.
Valency -2.
-2.
-2. Correct. Silicon.
4.
Metalloid,
4.
Metalloid.
Correct. Silicon is a metalloid. Valency is just 4. Okay. Argon.
Noble
Noble
gas.
Noble
Valency
gas.
Noble gas.
Argon is a noble gas. Valency is 0. Which element has duplet configuration?
Helium.
Helium.
Name an element which has octet configuration.
Neon.
Argon.
Argon. Neon, argon both have octet configuration. Okay. Then, okay, then shall I stop here?
Yes,
ma'am.
Okay. Have a nice day. Thank you. Bye.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Excuse me, ma'am, I have one doubt.
Yes.
Ma'am, in the hydrogen, why the valency is +1 if it is both a non-metal and a metal?
See, last year also under hydrogen chapter you learned, correct? Hydrogen, it has 1 electron in its valence shell. If it loses an electron, that 1 electron, if it loses, that is nothing but 1 positive charge which is there. So that is H plus ion, which is also called, which is nothing but a proton. Okay. Hydrogen atom is also placed, if you look at the periodic table, it is being given position under group 17 elements, which are halogens. Halogens have generally 7 electrons in their valence shell, like fluorine atom, 2, 7. So having